This week on Cloud Slaw, I'm going to teach you how to do a little crypto mining. In our last lab, Explore the Power and Pain of User Data, we learned about the user data field and how we can use it to pass information into our instances when we launch them. In that lab, we embedded some secrets and then explored how those secrets could be exposed if someone compromises the instance and poked around the metadata, or if they got credentials to make some API calls. We also saw how CloudTrail logs mask the data, which can make it a pain to investigate after the fact. In that post, I mentioned that there are two uses for user data. And sometimes I type it out as user dash data, and sometimes as user data 2 words. Just depends if I've been working a lot on the command line or if I'm just writing it in a blog post. Anyway, to pass information into an instance or container, such as license keys or oh God, don't put secrets in. Don't put secrets in user data. So that's the first use case. That's what we covered last week. The second use case for the user data field is to run commands when the instance launches. Now, how do you do this? Well, it's easy, assuming your operating system is using something called Cloud Init, Cloud-init. This is a widely used open source project that enables the initialization and configuration of cloud instances. It was developed back in 2009 by Canonical, which is the company behind Ubuntu. And Cloud Init has become the standard tool for customizing cloud instances across various platforms, including AWS. It allows users to automate the process of setting up a new instance by executing scripts and applying configurations at launch time. My first automations that I ever did in cloud used Cloud Init, and it customized EC2 instances for the because it was really painful to create machine images back in those early days of cloud, and I had to come up with a technique to support the Cloud Security Alliance training stack. Using Cloud Init, I could configure entire application stacks with it. Look, here's a snippet of what it looks like, and this is just part of what a Cloud Init stack would, or sorry, a Cloud Init would look like to deploy WordPress into an instance, and I cut it off for space. And you can see right at the top, we say cloud config. We do some updates and upgrades, so that updates the operating system. And then these are the packages that we want to install. And then there's a bunch of command lines. We run those command lines. And there's other sections that are in here as well. Now, this is clearly a powerful tool for attackers as well as for developers and operations folks, because if they can compromise credentials and they have the privileges to run an instance, they can use Cloud Init to run things that you may not want running. So how can this be a tricky attack? Well, it's often abused for installing crypto mining and malware into somebody's environment in a way that's harder to detect than if the attacker, say, tried to run their own pre-built image that said, angry attack image from hacker, please run this. So what they can do is they can use Cloud Init to actually take a standard image type, like the Amazon Linux that we've been using in all of these labs, and most defenders do allow those standard types. But then they use Cloud Init to give themselves access or to run automated or manual attack tools, because they can load up the tools, they can instruct that instance to make connections back to their environment. There's a low, or they can run completely automated attacks, for example, for instances that don't have internet access. And as you saw last week, the user data doesn't show up in CloudTrail logs, so you can't write a rule in your security monitoring tool that says, alert me if some jerk tries to use user data to mine Dogecoin. I don't know if it's a Dogecoin or Doggy Coin. I just call it the Elon is here rule 1 in my tool. Now, I largely have moved away from using Cloud Init because these days it's much easier to build custom images, especially with automated build pipelines. And in fact, I think I only use it to run like pretend attacks and trainings at this point. But it does still serve a purpose, and it can be a quick way to test some things out. And sometimes you might use it to auto register different services or different connections to your management tools when you first run an instance in an environment. And it can do some scripting and other things that are going to change based on like we're running in development versus production. So there's a lot of legitimate reasons to use Cloud Init, but it is clearly ripe for abuse. And so our key points for the lesson today is to remember that Cloud Init, it's a software package and you have to install it in your operating system, but it's pre-installed in many cloud instances. And this will run configuration scripts when the instance first runs. And that is a key point I missed before. Cloud Init only runs the first time you boot an instance up. Then, if an attacker has the right IAM privileges to run an instance and they can insert a cloud init into that user data field, that allows them to run their own code and they can do kind of almost anything. This is in terms of real world attacks, it's most often used for crypto mining. It's sometimes used in certain other more advanced attacks as well. Okay, let's see what it looks like in today's lab. This is another fun one where we're going to simulate attacker activity and we're going to see if our detections pick it up. Let's jump right in. Start, as we've been starting most of our labs recently, by going to test account 1 and administrator access. Yours might be white, mine's black. I don't know. It just depends on what the browser picks that day for Amazon. Then we need to deploy our standard stack. So we'll go into CloudFormation and we'll go to create stack, choose an existing template. And the one we want is in the blog post, but it is the same one we used in some previous labs, public VPC template. And this is a pretty standard one. To be honest, you could probably leave this up and running in between trainings. That's your choice. Then we're going to type in S.L.A.W for the name and click next. Scroll down, click I acknowledge that AWS might create IAM resources with custom names. Click next. Scroll all the way down again and click submit. And as we've been doing for these, I'll go ahead and pause my recording while that deploys. Should just take a couple of minutes. Okay, that took about 3 minutes for me as usual. Let's go ahead, and this just created a basic VPC like last time. We do have our session manager role, but we don't even need to log in today. This is that fast and that easy of a lab. Next thing to do, let's go to services and go to EC2. And that should be on your pick list like it's on mine because we've been doing a lot there. Then go to launch instance. And the instance name, we're going to call it Miner 49er because that way we're going to know exactly what it is and what it's going to be doing in our environment. Now look, this is not going to actually be doing crypto mining. We are simulating what a crypto miner would do, but we're doing it in a way that will trigger guard duty. That's going to make sense as we get a little bit deeper into it. Okay, so scrolling down here, we want to stick with Amazon Linux free tier, all the usual settings. For the key pair, as usual, we do not need a key pair because we're not silly and we're not using SSH. And then we're going to use the one VPC that we have loaded up there. And we're going to go to select an existing security group. And we're going to click our default group. Kind of funny, I forgot what I had named these. So our VPC means exposed, which is true. And we've got a public subnet on there, which is also true. Now, if you recall from the last lab that we have to go to the user data field, and it's way at the bottom of the advanced details. Just up at the top to be safe, if you do want to log in and see what's going on and look at logs, you can go assign the SSM client role. I will not be logging in. This works completely without you actually having to log into the instance. It's all automated. Then we scroll all the way down to user data. You want to go to the blog post for this lab, and it's called the Cloud Init blog post, and copy out the command line I have in there. And so as you saw my other example, cloud config is what's telling the Cloud Init software to run, and we have run command. And the command we're running here is curl, which is just connect to a URL. And in this case, xmrpool.minergate.com. I've never actually looked that up to see what it is. And then we're just setting up some randomness and some output here to it. So the reason that this works to trigger guard duty is because guard duty is set that this is considered a URL for crypto mining because it says MinerGate, so it probably is, and guard duty will alert on it. The way crypto miners work is that they do the work locally on your system, but they have to connect into their connection pools in order to know what work they're supposed to be doing. And look, I'm no crypto mining expert. I've never done it myself other than in these labs and experiments. What I do know is that this is a pretty reliable way to trigger guard duty. So with this setup, what's going to happen is the instance is going to run. And as it launches, right on the first time that that instance launches, it's going to run this one command. Now you could imagine an attacker would be able to insert more complex code in here, like the full application stack that I showed you before for running WordPress, or in their case, they'd be running attack tools, or this would be how they would insert the crypto mining software onto an instance. All right, let's get that going and let's go launch instance. Now we'll go into view all instances, and you can see that this is initializing and running. Here's the deal. There's nothing else for you to do except wait to get your guard duty alert. And if you've been following along in these labs, you're going to get that alert in your email. Now, in my case, to be able to show you this, I ran it yesterday. Did some testing, made sure everything worked. Actually worked the first try. Yay me. And we're going to go ahead and I'm going to load up guard duty. So what you're going to see is not this alert. This will take maybe up to an hour. In my case, I think it was about 20, 30 minutes before I got the alert, but you do need to wait for the guard duty alert to come in. I'm going to show you what it looks like in the guard duty part of the console, and you'll get the email again if you've set things up the way that we have it set up. So if I go into guard duty, and we should see right away, oh no, my findings aged out. So let's go look at findings. Oh, no, you can see it's here. So this is the old findings you can see were there historically. And there was the earlier one we did with SSH brute force in that lab, still shows up in the findings. And you can see that I was also able to trigger that cryptocurrency mining using the exact same technique that I just showed you how to use. And it gives you all the information, the IP addresses and what it connected to. And in this case, it alerted because it was connecting to pool.minergate.com. That's it. So this shows how powerful and how risky Cloud.init is. I may not use it that much anymore, but there are places where it can be commonly used. It can be really good with for doing some early prototyping and testing things. The other thing about Cloud.init is it can also be supported within containers. So we do see Cloud.init used there because you can insert variables into that user data field when you launch something to reconfigure it. So it's not just used for stored secrets. It can be used for configurations. I may have other techniques I prefer. This is still a very valid one. It's a very valid tool to have out there and use, but it does have risk. And this is an example of how attackers use it in the real world to do crypto mining and have you pay the bill. Thanks, everyone. See you next week.